ask. And the question might make me look stupid, but I don't mind. And this question is for people who have studied geography. So I know that they said the Earth is round, like it's spherical in shape. But my question is, where are we on that planet Earth? Now let me show you what I'm trying to explain. Pardon my drawing. This is Earth. Earth is round, right? We are inside. There's a map. There's everything. So my question is, where are we? Are we here on top like this? And there's now America. There's now Nigeria. There's now UK. And all of us like this on top. And that means that there's nobody on this side. Because there's some countries on this side. That country will fall off, right? Everybody there will die.
Those were very nice questions, and it's a very it's a beginner question that everybody gets to ask in geography class. But if you didn't do geography, it's going to be like a puzzle to you. So let me explain it. I was tagged on it by one of my fans that have watched me dispel flat earth theories. Okay, so here, this is what the earth looks like, and you're here walking around. Okay, so let's say these white places are water, ocean. 70% of the surface of the earth is ocean water. All right, and this water is not drinkable because it has hot salt. Okay, the drinkable water is 0.01% or so, just very small. So which means earth is not even habitable. We are managing to survive. I'll go deeper on it later on. But let's say these blue spots are the continents, the land that are on the surface. These blue spots. So this could be Africa. We're here walking around. If we want to go to America, we have to enter ocean and then cross the ocean to America. Okay, we have to cross the ocean to America. So it's either we'll go through ship or through flight. We'll fly over the ocean. There's no other way. Okay, so if we want to go to maybe India, we'll cross the ocean again, the Pacific Ocean, from Africa to India. That is the way it is. So we are walking on land. Now she says something interesting, that people here will fall off. In physics, right, we deal with forces. So if somebody is falling off something, it means something else is pulling the person down, or something is pushing the person down. That's Newtonian law, right? And a body continues in its state of rest or uniform motion unless acted upon by something else. That is Newtonian physics, right? So if somebody is falling off, there's something pulling the person down. So what is it? Nah, anything here cannot fall off. You can even demonstrate it with ants too. If we place an ant on this ball now, do you think the ant will fall off when it comes here? No. It will fall off. It will just keep going round. Try it, right? The ant will not fall off. But it's not for the same reason, okay? The ant has better grip. But then, in physics, everything has something called gravity. Anything that has mass has gravity, period, in physics. And everything is in free fall, according to Albert Einstein. Free fall means that everything is floating in space. Like this ball now is floating in space, but of course I'm holding it, right? So, but then bigger bodies that have bigger masses, right? They attract, they pull others because they have bigger gravity. They pull others. Gravity acts like a magnet. Okay? So look at this. There's a magnet inside this, all right? And there's a metal inside this. If I bring it close, you see what happened? So that is why you're able to walk on Earth, because at the core of the Earth is round like this. In the middle of it, inside this ball, in the middle, there's a spinning core. This core is made up of things like molten magma. It is so hot that everything there has melted into one gooey soup. Hot, very hot. I don't know if you've seen when volcanoes are spitting out. That thing that is coming out from volcanoes is coming from Earth's core. That is how the core is. So it's spinning. It's not just spinning. It is very powerful. It has high gravity, so it's pulling everything towards itself. So the way the Earth is now, if a comet, all right, or an asteroid is flying past Earth, that core inside will pull it. It will crash into Earth. That's when you see shooting stars. Something flying past, that thing will change its direction or trajectory. So let's say that something is flying past Earth like this in the sky. The core of the Earth will pull it. It will change and start circling the Earth. It will keep circling until it crashes into Earth, because the core is so powerful. And that gravity is so powerful that it attracts everything. You know, magnets only attract metals, right? So the Earth has a magnet. It's on its own. It has magnets separate. There's a magnetic pole separate. But then the earth has gravity. Gravity pulls everything. Magnets pulls like only metals. So if you want to know the direction of the magnetic pole of the earth, it's usually slanty and it moves, it changes, right? Because the earth is spinning. After some years, the magnetic pole will spin towards one side and change like this. So the way to know it, and you can use it to find your location if you're lost in the forest, right? Is you get a bowl. Do I have a bowl here? Get a bowl of water. Get a bowl, put water there, all right? Then get pin. You know the pin that you use to stitch cloth? Try and balance the pin on the side so it will lie on the water. If you are careful, the pin can float due to the surface tension of the water, right? If you balance it, you leave it like that. After some time, the pin will reposition to face north-south of the Earth magnetic pole because the pin is metal and the magnet inside the Earth is acting on the metal. The metal will align. After a few minutes, like 1 or 2 minutes, the pin will change. So if you have 10 bowls and put 10 pins there on top of the water there, all of them will face the same direction. Now, some animals have a sensor in their brain that they can sense it. A human being is so light, we don't need it, right? But things like dogs and birds have it. That's how they know where to fly to during winter and during summer. They can track Earth's magnetic pole. So dogs, for instance, can only shit, if the dogs want to poo-poo, they can only poo-poo facing north or south. So they use the magnet in their brain to orient themselves and poo-poo facing that. So when a dog wants to poo-poo, it will keep turning around. You see the dog, first of all, turn round, round, round till it finds the alignment, and then it will poo-poo in that alignment. Scientists don't know why dogs have to face that direction to poo-poo. Nobody knows. You understand? So we are on Earth, okay, on top of it. Then where we are standing, there are gases. Remember that the Earth's magnetic core, not magnetic, but the Earth's core is pulling, the gravitational core is pulling everything. So it's not just pulling you and I, it's also pulling gases around. The oxygen we breathe, the Earth is holding it. Okay, then the lighter gases are at the top, the heavier gases are at the bottom, more like the gases that have more mass. Okay, they are more tightly packed. The ones that the molecules are spaced out are at the top. All right, that's the same thing with land. Land is more tightly packed than your body. That's why you are walking on land instead of sinking. If you go to land where the molecules are spaced out, you will start going in. If you try to walk on water now, you will go in because the molecules on your body are more dense. Density is the word. They are denser. They are more tightly packed than that of the water. So you will go down until you reach rocks that are more tightly packed than your body. That means the gravity is pulling all of you according to your density. Do you understand? So now, this thing is pulling the denser objects on Earth are closer to the core. You understand? The denser ones are closer to the core. The lighter ones are outside. It's just like you fetch water. Imagine that there's a dirty water in the stream, dirty stream, right? You stir it, and then you put a bowl and fetch water there. If you keep that water to settle, you will see that the heavier objects, not heavier now, but the denser objects will go to the bottom, followed by the next ones, followed by the next ones. At the top now, you see clean water. Water is like lightest. If you have plastic, water is denser than plastic. Plastic will float on top of the water, and so on. Then you see gas. Above the water is gas, oxygen. We don't see it because we use it, right? Like fishes don't see water because they use water. Then at the top now, you start seeing ozone, or the ozone layer, which is oxygen, O3, something like that. Then you start seeing outside space. So as the Earth is spinning, it's spinning with all the gases. It's spinning with you on top. You're on top of the Earth, moving around your business, but the Earth is spinning with you. The gases are spinning, and the Earth is spinning around the sun. It's chasing the sun. The sun is traveling. The Earth is chasing the sun now, like this, spinning. Too. But you don't feel all these things because of what we call relative velocity. Okay? So, for instance, if I'm sitting in a car and the car is traveling at 300 kilometers per hour, basically the car is flying. Will I feel it? I will not feel it. We only feel acceleration and deceleration when the speed is increasing or decreasing. That's when we feel it. As long as it's stable, we will not feel it. So if the Earth is spinning, you will not feel it because it's spinning at a uniform speed. The only time you feel it is if the Earth suddenly slows down or more. Everybody go by now. People will fly off into the sky. If imagine this thing spinning like this, suddenly stop. anything here will fly off based on that velocity. So, but the Earth spinning, so the Earth spinning is relatively constant. That's why we don't feel it. It's not increasing speed, it's not reducing. Well, it's reducing, but so tiny that we don't notice it. Like, it's dropping by 1 second every 1 to 3 billion years or something. Because there's nothing really, there's no friction in space. Nothing is really slowing it down. It's just that because it has been spinning, it's slowing down gradually. So that's the way the Earth is. Now, if you want to leave Earth, you know the Earth is spinning. Let's say you want to go to the moon or launch a satellite in space, you know, the one Elon Musk is doing. You have to use a force higher than the one that the gravity is using to pull it down. So when they are building a rocket, they have to calculate how much force is the gravitational pull of the Earth. You understand? When they calculate it, now they know the force they have to build into the rocket to be able to launch out. If you don't have that much force, you cannot escape. That's why they call it escape velocity. You must reach escape velocity before you can leave Earth's atmosphere. Otherwise, if you go up, Earth will pull you down again. It's just like when you jump. Have you seen people in the Olympics jumping? When you jump, you still fall. The core of the Earth is pulling you towards itself. So for you to jump out of the planet and escape the gravitational pull of the Earth, you have to jump at a certain calculatable velocity. So if you reach there, if you reach outside space, you can now start rotating around the Earth, or you just leave, depending on your trajectory. Outside space, you don't need much fuel. The fuel the aeroplanes need and the cars need is because they are trying to beat Earth's gravity. Once you leave Earth's gravity, you don't need fuel. Any direction that you are facing is the one you will keep going forever in that direction. If you now want to change direction, that's when you need fuel. You get? So the Earth like this has more gravity than everything. You have gravity in your body. If you are close to an ant, your body is supposed to pull the ant. So if you are standing here and the fly is flying past you, your body is supposed to pull. Your body is supposed to pull the ant. If you are standing on Earth and the fly is flying, the gravity in your body is supposed to pull the ants to magnet to you. But it's not happening because the gravity of the Earth far outweighs both of your gravity. You understand? So it's kind of overshadowing your gravity. It's just like this magnet now is trying to pull this metal. But let's say I have another magnet right under here that is the size of a football field. Big magnet. It will nullify, or not nullify, but overshadow the magnetism between these two objects. It will pull two of them towards itself. That's why. So if you're in space and a small object is passing, that object will come towards you because of your gravity. And if you're passing close to a big object, you will go towards that big object. So that's why planets have moons. On Earth now, we have one moon, which is the moon we see in the sky. All right, it's trapped within Earth's orbit. Now that's the same thing with some bigger planets have bigger moons. Like Jupiter has like how many moons? 32 moons, because it's way bigger than Earth. Okay, so Mars is smaller than Earth. It has no moons, right? But they will always have asteroids, tiny little rocks moving around, trapped in the orbit. So many tiny little rocks. So this shape of the Earth means that if you start at any point on Earth and you go around exactly without changing direction, if you just keep going straight from where you are without changing direction, after some months you'll come back to exactly where you started. That's proof that the Earth is round. Okay, so if you have the pilot flying straight without changing direction, they will still come back to where they started. You get? So what are the satellites doing? Satellites are rotating around Earth. There are about 3,000 of them, but they are trying to push it to 9,000 by 2030. So tiny little communication devices. They are little based on the size of the Earth, but they are really big. Some of them are the size of 5-story buildings, 10-story buildings in the sky, moving around. So when I want to call you, right, my phone, if I'm on Earth, if I want to call you, let's say you're here in America and I'm here in Africa and I want to call you, my phone network will connect to the satellite, the nearest satellite at the sky, and that one will beam that network to your phone here. This is how Starlink works. All right, but the ancient communication devices we used to have work with undersea cables. So this is America, this is Africa. They put a cable underground from America to Africa. They buried it at the bottom of the ocean all the way to Africa. So because of when they came to Africa now, they started connecting from mast to mast. That's why MTN has masts. You understand? So now if I want to call you, my phone network will connect to the nearest mast, to the nearest one, till it gets to the underground cable and crosses to US, and from mast to mast it will locate the person. That's the ancient one. But Elon Musk came up with the one of the satellites. So if you think the Earth is flat, show us one thing that a flat earther has invented. Nothing. That's the same way that Google Map traces your location. Okay, so this is North Pole, this is South Pole. All right. So if you're here, Google Map will calculate based on this distance to North Pole and be able to tell where you are. So when you're driving with map, it's using the shape of the Earth. Now, some countries located here have ice, like Europe, Iceland, Greenland, okay, North America, Alaska. They are located towards the north here. So they have ice. And the ones here have ice to this Antarctica. Countries close to Antarctica are usually like South Africa. If you go to Lesotho, it's always having snow. South America, and even Australia, some parts of Australia, they are closer to the bottom here. Okay, the North Pole, Europe. Africa is close to the middle. Our ancestors chose the best place. So why is Africa, Central Africa, right, not having snow? Because it's closer to the sun. Imagine that the sun is here. Light or heat traveling from this sun to this place, it will reach here faster than it will move from here to here. You see, here is longer distance from here. Imagine that the sun is like this. Distance from the sun to the North Pole is longer. That's why this place is always frozen part of the year. And then to the South Pole is longer. But Africa is in the middle. So Africa, parts of Asia, parts of South America. Because of that, there is a lot of heat here. So the sun is getting here faster. So people around Africa develop black skin. That's why I'm black. So that we can be able to cater for the sun rays. Which means if you're black, the sun is your best friend. It's going to heal you of many diseases. Your body needs it to synthesize vitamin D. And even depression. That's why when most people in Africa travel to Europe, they enter depression because they're not getting enough sunlight. But people in Europe, their body is evolved for such. Their body can make vitamin D faster with even the smallest light. And they need sunscreen to get to the sun, to get outside. But you in Africa, you don't need it. You get outside, you do your business, and you go in, and you are completely healthy. So that's why we Africans are here. And we are black in complexion. Not just black, our noses are wide. See how big my nose is? So that we can take in more air, because the air is humid and hot. So we need to take in more air, which means our lungs are bigger. That's why we can run longer distances. If you look at the Ethiopians, no matter how fast you run in that marathon, you're not going to beat those 3 Ethiopians. If they show up there, just start counting your position from number 4. You understand? So that is, we evolved for this, for those doubting evolution. If you look at people living close to ice, their skin is closer to the color of ice. You understand? So that they can cater for the little sun that is coming and the high cold. So their nose is narrower, so it can take only little air, so that their lungs will not freeze. If I go to an ice area with this my big nose, inside my body will freeze before the outside self, because I'll be breathing too much air. You understand? I'll be breathing too much air, cold air, and it's going to go and freeze me. That's why we blacks struggle to survive in some countries. I went to some countries, I went to a certain country, the outside temperature was 16 degrees centigrade, which is the temperature of AC. Bro, I nearly froze at 16. They were laughing at me. The white guys there. I was wearing sweater upon sweater. 16. There's a guy, you never even see snow. You never reach 0 degrees, -1, -2, -10 degrees centigrade. You are freezing at 16. You understand? So, because I'm from Black Africa, right? We're not used to that. My body is evolved for a different kind of weather. So, when you see people asking, say, claiming flat earth theory is just conspiracy. They don't have any basics for that. And if you ask them to prove the shape of the earth, they'll start attacking globe earth with fake news without actually proving the shape of the earth. So if somebody ever tells you that the shape of the earth is flat, tell them it's a triangle. Let them prove the triangle earth theory first.